Okay, this is an application problem for a derivative, and I know it's an application problem because the key phrase here, how fast was the federal debt increasing? It's asking me for a rate of change, right? How fast was something increasing? How fast was it changing? Okay, and anytime I'm asked that, the derivative comes to the rescue because the derivative gives us the rate of change of functions. Okay? It tells us what is the rate of change of the output with respect to the input at a particular value. Okay, so that's the first thing, is I know that I'm going to need a derivative because of this rate of change question. All right, so let's go ahead and find that derivative. The derivative of d with respect to x is, let's see, 3.26, that derivative is 0, plus the derivative of 0.472x is 0.472, minus 0.1684 times 2x is going to be 0.3368x. Sorry, 0.2368. Let me fix that. 0.23. No, I was right. 0.3, right? Because 2 times and then add 1 from carrying. Sorry. Okay, 0.3368x plus, let's see, 0.0853 times x cubed. Let's see what that comes out to be. Do a quick calculation here. 0.0853 times 3 is 0.2559x squared minus 0.00065 times, we'll bring times 4. 0.0026x cubed. Right, so let me just double check my coefficients here. 0.1684 times 2.3368. All right, excellent. Okay, so that's our derivative. And we're looking for how fast the federal debt was increasing in 2000. But let's look back at our model here. It says d of x, where x is the number of years since the end of 1995. Okay, so in 2000, how many years after 1995 was that? That tells me that x is equal to 5. So the last step here is I will need to find d prime at 5. That will get me the rate of change of the debt in year 5. Okay, so I'll go ahead and let you plug that into your calculators, and when we do, we should get a result of 4.86050 trillion per year. And notice that since this is a rate, it's something per year, just like your speed is a rate. So it's miles per hour, or your gas mileage is a rate. So it's miles per gallon and that sort of stuff. So anytime you see are answering a rate problem, it always should have some per something, right? Per something. So in this case, the rate is an increase of $4.8605 trillion per year. So the output of the debt is changing at a rate of that per every change in 1 year. And that's only in 2000. Notice if we had asked at a different point in time, we'd get a different rate of change.